All right. So 1 through 3, anything you want me to talk about?
So did you like highlight on the diagram?
Say again.
So did you use that diagram?
So like that first diagram, I used like the yellow highlighter to tell me that 5 and 4 were not supplementary angles; they're actually complementary. My last class asked me about adjacent versus linear pairs, maybe.
Oh yeah.
So remember that supplementary just means that they add to 180. Linear pairs have to be adjacent. They have to be adjacent and add to 180. Complementary add to 90. So I think somebody was like, okay, well, 5 and 6, it says they're adjacent angles, and someone was like, well, how is that different than linear pairs? Linear pairs should make a straight line. Adjacent just means they're next to each other. So if you look at the green highlighting I did, the 6 and 5, they share that line in between 6 and 5. They share a side and share a vertex, so that means that they are adjacent. Now, because they don't make a straight line, they make like an angle. They're not a linear pair, but they are adjacent. And then 1 and 2 are a linear pair because they are adjacent and they're supplementary. They add to 180. Anything on 4 through 7?
So on number 5, the 2 angles don't have to be touching each other. But what about the in-between part? We don't write that angle that's in between the 2 angles down.
Let me see. So it should be all of them if it's not the in-between part. So I wrote RPS was given to me, this angle right here, and then I wrote SPU. So I extended it over a little bit to go all the way to SPU to get the bigger angle instead of just TPU, so I didn't miss that in-between part.
And that would equal.
Yep.
For number 7.
Yes.
We required to do both.
Nope, you can just do one. There's actually a lot of answers for number 7 with angles that are adjacent to TPU. So if I go look at TPU, they just have to share a side and a vertex. So like I picked the 2 obvious ones, like this one, SPT, and QPU. They like directly share that side. But I also could have like done a little weirder angle. I could have done a straight angle right here. RPU would be adjacent because they share a side. Because I'm thinking like this side and then this guy. Can I do QP what? QPR. Nope, those don't share a side. Right, but they have to share a side and a vertex. Good question. Actually, what's the name of this relationship between these angles? Starts with a V. Vertical. Vertical angles. Very good. Very good.
Say angle complementary, 2 angles are complementary. Could that also mean if 2 angles are complementary, could they also be adjacent?
They could be adjacent. They could not be adjacent.
So they don't have to be just one. They can't. They can be more than just complementary. They can be complementary and adjacent.
So actually, for the complementary one that I have up there, the 2 purple ones I did are the ones that are next to each other. So let's see, QPR and then RPS. Those guys are next to each other and they form 90 degrees. So they're complementary and adjacent. But I also did, let me erase these. I also did RPS and then TPU, and those are complementary because on like this one line, if I can like minus out this 90-degree segment that's gone, then these 2 that are left should add up to 90 degrees. So that's an example of complementary but not adjacent. You did not need both options for number 6 either. I just gave you both in case you were looking for both. All right, can I move on to 8, et cetera, et cetera, et cetera? Okay. I'll zoom in a little bit. So you can also see 6 and 7. Which ones? Okay. Yeah, so I can start talking about 8 through 11. number 8 says angle CEG and FED. So I have those highlighted in pink. CEG is this one right here. And then FED is this one up here. I know there's a lot of marks on my picture, but I've got those angles across from each other. Those angles across from each other are called vertical angles. And vertical angles are always vertical and no, 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 not complementary.
You said everything except for the
Congruent. Congruent. I don't think anyone said congruent. You said it first? Yeah, I was like, you said every other vocab word besides that. Maggie. Hey. It does not matter who said it first. Math class is not a speed race. Math class is the journey, not the speed at which you get there. Maggie. Could point to D do what? Yeah, I mean, the angle keeps going. So, if I'm talking about DEF, that's this angle right here. And then CEG is this angle right here. So they're vertical angles, so they're congruent. Were you talking about another problem, Maggie? Okay, Glenna? Okay. Anyone on 9 or 10? Which one, Van? No. Okay. 11 says ABD and FDE are vertical angles. ABD, ADB, the order in which I say them is important. This angle right here. And then FDE. BDA is fine. Perfect, Deb. So these angles, it says they are vertical angles. Is that true or false? True. You can think of them as two lines that intersect. Here's a line that intersects, and here's another line that intersects. And they're the two angles across from each other that are formed by those intersecting lines. We're going to keep talking about this one? Silas? So it's kind of saying, like, based on what's drawn, can we assume that? And what I'm getting at here is, like, unless something's marked, usually you can't assume that it's congruent. Unless it's marked, you can't really assume that it's perpendicular. So like number 9, the segments were marked. Like the segment DE and FE were marked as congruent. So because these little congruent marks are there, that means that those segments are congruent. Number 9 was because I knew they were vertical angles. I knew that vertical angles are congruent. The orange one didn't work. It was like these guys right here, BAD, and then BCE. These angles right here, like we don't know anything about. Like they're not marked. We don't know anything about those guys, so we can't assume that. But based on what we know about vertical angles, the last problem we did, we should know that those are vertical angles. That's okay. BDE and FDE, these guys are across from each other. They're vertical angles. Say again. Anything on 12 or 13? You don't have to highlight anything. I do that to show you guys what I'm thinking. So if I can put some highlight marks on there, then I can show you what I'm thinking. But you don't have to mark anything. All right, I'm going to move over to the back in a second. Are we ready for that? Okay. I'm going to look at number 14 first, and then we're going to look at 15, 16, and 17. 18 was a weird problem. We're not going to do it. I don't know what I was thinking. I messed up. So you can just cross 18 out. 18 gone.
Yeah, that was confusing.
I don't know what I was thinking. I don't know what I was supposed to go to, but
It was just
whatever.
kind of there.
it needed to go with some problem, and I didn't know where it went, so I don't know what I was thinking.
I didn't.
So, my bad. That's okay. Number 14, though, I gave you the picture that number 14 is. So I have a measure of TXS. I highlighted that yellow, and then I labeled it X plus 3. Again, you don't have to highlight or anything. I would label all your angles. Highlighting is just a way to keep myself in line. Then I did SXR and highlighted that all orange and labeled that, which looks like 2 angles, as 2x plus 9. Then I did RXP and highlighted that green and then labeled that as 4x minus 7. Once I labeled everything, it was really easy to see that all 3 of those were a combination, or they all added up to 180. So that whole line, PXT, that's a straight angle, it adds to 180. So I added up all of them and set them equal to 180. I kept the color coordinating going on a little bit so you could kind of see my thought process. But then I solved for X and I got 25. And then once I got that, my final answer was to find what measure of PXS was. And that's the green angle plus the orange angle. So I had to add those 2 expressions up, substitute in X equals 25, and then solve for that. And I got 152. I know. Someone came in and they know it's hot.
Good.
Yeah. Yeah, like someone in charge. And they're like, we'll deal with this, or we'll have someone come do a reading. I said, okay. If I don't see anyone by the end of the day, I'll send in a work order so it's not hot tomorrow.
They
did.
depending the air coming on.
Yeah. Before it wasn't even on. Now it's on. Is it cold over it, Elise? Yeah. Like it's not blowing hot air, but it's also not blowing cold air.
So it's basically circulating air.
Yeah. But also when it was cold air, it doesn't get like across the room. And again, I'm not an engineer. Obviously, that's why I'm a math teacher. Like I don't study that. I don't really know how that works. But you think that the AC should move its way all the way across the room? Or else I think our ventilation's got to be poor. Yeah, that's it. So sometimes like those first 2 desks, like last week when it was cold, those first 2 desks were cold and then we were like still hot over here. So
Yeah.
yeah.
I just don't get.
Yeah, I'm not sweating yet. I was sweating that first week when it was way too hot. Are you sweating, Van? Do you need to take your sweatshirt off? If you can't, you don't have to. As long as you have a shirt on, I don't care if it's not uniform. Okay, you just have a sweaty shirt. Yeah, you can take off your sweatshirt if it's too hot. That's okay.
I'm always ready.
Well, I'll say fix our AC. And then I'll make our kids get uniforms. Sorry, I'm feeling a little sassy today. Okay, I'm actually going to keep it so you can also see 14. You have to draw a picture for 15 and 16 and 17. I just drew a really giant picture. Yours doesn't have to be that giant. Okay, it says QR bisects PQS. So I'm going to immediately draw a picture. QR bisects PQS. So the big angle is PQS. I have that outlined in pink. And then it says QR bisects that. So R is a point somewhere in the middle, and it crosses right through the angle to cut it into 2 equal angles. So one of the angles is PQR, and the other one is RQS. And they are congruent. That's bisected. I've got 2 congruent new angles. I color coordinated them again just because I think that that's the easiest way to think about it. So I colored PQS as green, and I colored RQS as yellow. Then I went through my 3 problems, and I highlighted PQR as green, RQS as yellow, and then PQS as pink, and anything kind of in those orders if it's the same angle. It was really easy to see then which ones I could just set equal to each other. So 15 and 17, I could set those equal to each other because the green and the yellow angle are congruent. They're the same. They're equal to each other. So I just set the 2 expressions in 15 and 17 equal to each other. However, 16 is not equal to each other, so I have to approach that one differently. PQS is the whole angle, and then I gave you one of the parts. I gave you that PQR, the green angle, was x plus 11. If this angle is x plus 11, what do I know about the yellow angle? It's also x plus 11. And that means together, and together they add up to 4x minus 6. So I wrote 2 times x plus 11. You could have written x plus 11 plus x plus 11 equals that 4x minus 6. That's why number 16 looks different. It's not the same as the other two. Not the same as the other two. Okay. Questions?
How can you set measurement of QR to measurement of SQR?
They're congruent.
How can you tell that?
So SQR is the same thing as RQS. It's just written differently. And I know because QR bisects this big angle,
Whenever it bisects that,
it means that so when it bisects it into 2 new angles, those 2 angles are congruent. Yeah, bisect means that I'm going to have some congruent things in a second. Okay. All right, I'm going to scroll down a little bit. You'll still be able to see 15, 16, 17. Now you can also see 19, 20, and 21. 21, there's only so many ways to draw that. And just think of it piece by piece. So what I did first was I drew the linear pair and the vertical angles. So I know vertical angles were 2 lines that cross each other. And across each other, one was going to be 2, one was going to be 4. And then 2 and 3 make up a linear pair. So I just had to write it in the way that 2 and 4 were across from each other. And then 3 was on the same side of the line as 2. I'll talk about 20 in 1 second.
I'm just asking what that says 3x equals. What's that number?
210. Yeah. And then it says 4 and 5 are complementary. So I had to finish angle 4 off to make a nice right angle, and I called that angle 5. And then I've done everything so far, and the last thing is making sure 1 is adjacent to 2. And I was able to do that by just finishing it off by writing angle 1. There's only so many ways to draw that, so if you did not get that, think carefully about it. I won't necessarily make you draw that, but we use this diagram for a lot of things. Like this diagram is not going away. You'll probably see it on the quiz. You'll probably see it on the test. This is a really easy way for me to look at, ask you, what are linear pairs? What are vertical angles? What is this? What is complementary? What's supplementary? Blah, 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 blah. This diagram is going to be places. Yes, Megan? Yeah, perfect. I'm going to talk about 19 and 20 right now. Any other questions on 21? I thought that was easier to talk about first. Okay, 19 and 20 are kind of vocabulary questions. I need you to know that complement means that the 2 angles are complementary, which means that they add to be 90. So number 19 is using complement. So I drew a diagram where I've got 2 angles that add up to 90 right here. It says the measure of one angle is 5 times the measure of its complement. Well, its complement, I'm going to write that as x. The other angle, I'm going to write as 5 times that, 5 times x. The big mistake a lot of us make is you'll do 5x equals 90 and you'll forget to add your other x in there. Don't forget the complement has to be included. Uh-huh. Oh God, I didn't even do that. Number 20 is very similar. Any questions on number 19? The big thing on 19, you need to know complement means add to 90, and you need to use x also, not just 5x. Once you solve, it's really easy to go back and check your work. So I can say, okay, well, I know x is 15, and then 5 times 15 is 75. Does 15 plus 75 equal 90? Yes. For number 20, it's different because it says supplement, which means I need to remember that supplementary angles add to be 180. So this time I'm using a supplementary diagram. My two angles are going to sum to be 180. The measure of one angle is 30 less than twice its supplement. So 30 less than twice the supplement is going to be 2 times x minus 30. The supplement is just x. Again, don't forget to don't just do 2x minus 30 equals 180. Don't forget your plus x. That's a common mistake I don't want you to make. And then again, I can check my work. I can do 2 times 70 minus 30, and that's 110. 110 plus 70 is 180. Okay? Last couple. These problems I thought were pretty simple. No one's really asked any questions on them. You just have to look at your diagram and read what's given to you. I told you HKI is 48. And then from there, you need to know, like, what's 90, what's 180? How do I add or subtract to get one of these other angles? What angles are added together to get this bigger angle? It's just kind of algebra. As you go along, you can label them and just think about, like, what's being combined to get there. So, like, HJ, HKI, or HKJ, we know is supplementary to the 90-degree angle. So I know that that's 90 degrees. Yeah. Megan? 25 says 132. So I love that we're correcting our work. That is awesome, great behavior. What I want you to do, though, is before you take this quiz on Thursday, is try some of these problems again. These are the types of problems I'm going to give you. And so if you just, like, busy bee followed me around, that's awesome. But now, don't go back and be like, oh, well, I got the right answer because Ms. White went over it with me. Ms. White doesn't get to take your quiz with you on Thursday. So I want you to feel confident. I want you to try these on your own. What I'm about to do is collect all the paper versions. If you did this on school, would you please turn that in now if you haven't turned it in yet? If you have a paper copy, I'm gonna collect that, and then I'm gonna pass back all the papers that I have for you. So you should have every piece of homework I've ever given you. If you do everything online, you have access to it all, so I don't need to do that again. It's on 1-3 through 1-5. So not 1-1 or 1-2. We already took a quiz on that. Point line plane, that stuff. Oh, but before we do that, let me come around and get that. We do need to finish 1-5 though. So I think I need to finish 1-5 notes. Did we do this back page?
Yeah.
There are 3 pages. Did we do the whole 3rd page?
Yeah.
We did?
Yeah, we were awesome.
I will even went over angle bisectors.
Yeah. Wait, what?
Okay. I'm going to do the 3rd page. Okay. I think we were hustling through the last 2 on the 2nd page.
Yeah.
Okay. So we're going to meet here on the 3rd page. I'm going to come collect any homework. If you have not turned your homework into school, would you please turn that in now so it gets on time? If you have a paper, let me take it. This will only take a few minutes, so I do want to make sure that we're good. No, it's academic. It's all the same stuff. And then we're going to do the study guide together.
When are we going to do that tomorrow?
Or not together. You're going to work on it at the end of class. And then we'll review it before we have our quiz. Yeah. You have to wait until I'm done teaching so you can use this quiz. All right, guys, listen up. So we're on the 3rd page of 1-5. Everybody with me? I know you've been working so hard today, and I'm so proud of you, but let's focus for another few minutes. The last bit of class, we're going to work on our study guide, okay? As soon as you leave this classroom, I'm going to put up the key online so you can check your answers. You guys are lucky because you don't have to take it tomorrow. You take it on Thursday. So if you need any help, you have today after school, tomorrow before school, tomorrow after school, tomorrow before school, Thursday before school. If none of those times are good for you and you want me to Zoom with you, I'd be happy to, but you have to ask me. I'm not going to like send it out and be like, whoever wants to Zoom. No, you ask me and we can set something up. Buena? I'm only off alpha. Yeah. So I've had some long days, but if you have free alpha, I'd love to help you, but no other periods. I have classes all the others. Okay, so we're looking at number 3. First thing I want to do is I need my X's and my Y's to go together. So let's highlight, here are my X's, here are my Y's. I can't solve an equation with 2 variables. I can only have 1 variable per equation. If I'm looking at my X's, what's the relationship between those angles? What'd you say? They both have the number 5. Austin? They equal 180. Awesome. Do you remember the word that we used for that? Supplementary. And then what's another special word for these 2 angles that are supplementary and adjacent? Linear pairs. Did I hear that? Okay. Okay. Well, whatever. Okay. So I love that, Austin. Thank you for telling me they add up to 180. You got the gist of it. So we're going to set them equal to 180. 4x minus 5 plus 2x plus 5 equals 180. Now that I have all my x's together, I can solve for x. I have 6x. My 5's cross out. 6x equals 180, so x equals 30. Awesome. The hardest part is just writing the equation. The hardest part is going from the picture to the equation. All right, now we've got a couple options for the y's. We can either do the y's together. Yes? Okay, Max, how are those guys related? It's the same as above, right? So they're also linear pair, and they're also supplementary. Awesome. So I'm going to set them equal to 180. Another thing you could have done, and we're not going to do, is we could have gone like this. I'm going to do it in purple. I could have gone like across and done vertical angles are congruent, but I would have to plug 30 in for that x right there. Does that make sense? That's what we did on number 2. We set our x's equal to each other because they were vertical angles, and vertical angles are congruent. But that was a little too much work for us here, so we just decided that we're going to do the supplementary one. So 3y plus 5 plus 7y minus 25 equals 180. Oh, I ran out of space. Someone's breathing like Darth Vader. I don't think it's done. Was it you, Silas, as you're drinking? Your water makes weird Darth Vader noise. All right, I'm just solving algebra. You guys are good at this, so I'm not talking about it.
Speedy quick.
Speedy quick. So the whole thing that I think that you guys struggle with or will struggle with is going from the picture to the equation. So identify, are they vertical and thus congruent? Or are they linear and thus supplementary? You want to figure out if you set them equal or add them up to 180. Those are kind of your 2 options. Okay, I'll leave that up so you can still see it if you're looking. And the next box is just telling us what you can assume to be true and what you cannot. So basically, like, unless there's a plane drawn, if there's no plane drawn, you can assume that all the points and lines are in the same plane. I'm not going to throw a non-coplanar point on you there unless there's physically a plane drawn for you. Okay? We also can assume that if they look like they're collinear, they are. If they look like they intersect at a point, they do. If it looks like they're adjacent, they are. What we cannot assume is if they look like they're perpendicular, that does not mean that they are. And just because they look like they're congruent does not mean that they are. So you cannot assume congruence unless I have marks. Unless I say this is congruent to that, then you're allowed to assume it. But looking at this picture right now, there were no marks. You cannot assume anything is congruent. Yes. The last type of problem, I think there's some on the review sheet. We can practice those. It says a blank is a ray that divides an angle into two congruent angles. We call that an angle bisector. An angle bisector divides an angle into two congruent angles. So I've got two examples that we're going to do those. All right, so BD bisects ABC. What do we know about these two angles right here? They're what? They're congruent. So can someone set me an equation? Perfect. If they're congruent, just set them equal to each other. Add x to both sides, minus 1. This all. Again, the hardest part is setting it up. Angle bisector means they're automatically equal to each other. Similar idea for the next one. It's also an angle bisector. Can someone set me an equation for this one? Ava. Perfect. Minus x minus 31. X equals 5. All right. That is going to be it for today. So if you did not get a review last week, I have some papers I'll pass out. If you did get a paper review, you can get that out. If you want to do it on Schoology, I think it's under today's date, which is Tuesday the 1st, September the 1st. This is what we're working on. You are free to work with your notes. You're free to work with a friend. You're free to ask me questions. You're free to use a calculator. Like, I don't really care. This is your time to study. I want you to make sure that you're doing this good and correctly and asking questions and checking yourself, blah, blah, blah. I'll put the key online after this class is over. Okay? All right, I am going to stop sharing this, and I am going to stop recording.